Hello, and this is going to be your demonstration of the properties of water lab part 2. Um, in this lab, I will demonstrate 3 different activities so that you can get a feel of what this lab was about. And then you'll be able to use this demonstration video to answer the questions that are found in your Properties of Water Station Lab Part 2 document. So I have the document pulled up so that we can see it. So we're going to start with Station 4, and it's number 4 because we did 1 through 3 2 days ago. So for Station 4, we're looking at water as a universal solvent. I cannot talk right now. Universal solvent. So read that paragraph, and then we're going to get started. So if you need to pause to give you time to read the paragraph, please do. So it says Part 1, solubility of various solutes in water. So we're going to observe how water behaves as a solvent. We're going to attempt to dissolve a variety of substances in liquid water. And to do so, we're going to measure 50 milliliters of water into a 100 milliliter beaker. So actually, I don't have any 100 milliliter beakers right now in the lab, but I have a 250, so we're going to use that. That's my 250 beaker. So I'm going to put water in here, 50 milliliters. And if you were to try to do this lab at home, which you can, because we're just using regular household things that you have, then you could just use a cup. And a cup is normally 250 milliliters total because it's 8 ounces, and that's how many milliliters is in 8 ounces. So you can just fill the cup like a fourth of a way and do this lab. So the first substance that we're going to dissolve is 0.5 grams of NaCl, which is just table salt. Notice that I have ionic in the parentheses. That means that salt is an ionic compound. So dig back into your chemistry knowledge to remember what that means. So I have my salt here. I've actually already pre-measured it. Here's my salt. And I'm going to pour that into my beaker. And I'm just going to swirl it around. Keep moving it. Oh, without wasting it on my laptop, as I just did. So I'm going to keep swirling, 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 swirling. You'll start to notice that, can I not make a mess? You'll start to notice that it is starting to disappear in there. It's dissolving. Put that up there. Notice you can't see any of the salt particles because the salt has dissolved. Ta-da. All right, so you need to put your results in the table. You see it dissolved. I'm going to rinse this out. So off the camera, I'm just rinsing the beaker out really, really well. And I'm actually going to go ahead and get a paper towel. So you get to see me walking in the lab. I'm back. I have paper towels. So I'm just going to dry this beaker off. And that's just because I didn't want to dirty up too many beakers at the same time, because I didn't have to wash them. So we're going to dry this one off and get it all clean. Dry my laptop off. And I'm going to put some more water in here so we can move to the substance for beaker 2. All right, so I now have 50 milliliters of water again. And now it says to put 0.5 grams of sucrose, which is also known as table sugar. Notice that it is polar. So here's my sugar. Just shake that, make sure all the granules are really loose, so they'll come off of there. Wanting to adhere to the surface, so I'm just going to help them along. All right, And then now I'm going to swirl this around and keep swirling. So notice, first of all, you can see, oh, there it is. You can see the sugar in there. Keep swirling it around. And we're swirling, and we're swirling, and we're swirling. Swirl, 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 swirl. And now look, we don't see the sugar anymore. So that means that it has what? Dissolved. All right, so that was our beaker 2. So I'm going to rinse this off. And I'm just going to dry the beaker again. All right, I'm going to put some more water. So we need another 50 mils of water. So here's our water again. Now it says we're going to squeeze one squeeze from a transfer pipette of vegetable oil. So here's our vegetable oil that I have in a flask. Here's our transfer pipette. If you were doing it at home, if you have any type of like medicine dropper, you could do that. Or even from this lab, you could just use like a spoon and just spoon some into your glass of water. So take some out. So here's our vegetable oil in the pipette. I'm gonna put here. Squeeze it in there. All right, so you can see that. Kind of have a layer of it on top. I'm going to swirl, 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 swirl. And if you look here, let's see if you can, I can actually help you if I have the camera. See that vegetable oil on the top? It's not going anywhere. Even if I swirl again, swirl, 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 swirl. Let it settle. Still on the top. So our result there is what? Not dissolved. Let's rinse this out. You just hear the water in the background. That's the beaker out really, really well. I'm gonna dry it. And I'm gonna grab one more pipette. I'm back. All right, last one, part 4, or beaker 4. So now we have one more beaker full of water, 50 mils, and it says we're going to use ethanol. And this is just regular isopropyl alcohol that you could buy in the health department of any store. Um, we call it rubbing alcohol. So I'm going to pipette some. So here is our ethanol, and I'm going to squeeze that into the beaker. This is what it looks like before I swirl it. Can you see where it's a little cloudy in the water? And I'm now going to swirl it around. Really, really well. All right, now you'll notice that it dissolved. We don't see it. Just looks like regular water, but we know it's not because we put alcohol in it. All right, so now you're able to answer the questions underneath, answer questions 1 and 2. And then we're going to move to the density part for part station 5. I'm going to pause for just a second. All right, guys. So for this part, it's looking at density. Tells us that water is one of the few substances that are less dense as a solid than as a liquid. While most substances actually contract when they solidify, that means that most substances get smaller when they become solids. Water actually expands. And you know this because when you put a bottle of water in the freezer and it freezes, have you ever noticed that it'll expand? Um, and this is because of the hydrogen bonding between water molecules. The hydrogen bonds like actually stretch out. So for this one, we have a beaker of water and we have ice. I'm gonna put the ice in the water. Notice what happens when I put it in there. It floats to the top. So that was a really, really simple station, really, really quick. So all you have to do now is describe what happens. And then you want to explain why this property is important to aquatic organisms. And I'm going to give you a little hint for that, number 3. First of all, we know aquatic means they live in water. And think about it. If it's the water is somewhere where it gets really, really cold, like in Alaska, we use extreme cold like that. Think about why it is important for ice to float to the top when water freezes in relation to a pond of water or a lake. Why would it be important for it only to be having ice on the top and not for ice to freeze from the bottom, for water to freeze from the bottom going up? So really, really think about that. Imagine you're a little fish swimming in the pond or in a lake, and you have to rely on that this particular property of water. Why would it be important? All right, so let's move to the last station. And now we're going to be looking at how adhesive water is. So read that little paragraph. While you're reading it, I'm just getting what we need. We need 3 graduated cylinders. These are my graduated cylinders. If you're doing it at home, you can use a cup. It's fine. All right, and it says we also need a paper towel, and the paper towel is going to be cut into 3 different widths: 1 centimeter, 2 centimeter, and 3 centimeters. Doesn't matter how long it is, but we just want to make sure the width is correct. So I'm just going to measure this out really quickly, and I'm going to cut the paper towel. So here's the paper towel. Here's my ruler. I'm using this centimeter side. And I'm just going to cut them out. I guess I could have cut them before I started this video, but that would have been too much like right. So I have my 1 centimeter. Here's my 2. And then I'm going to cut my 3 centimeter wide one. Here's my 3. So I have my different, uh-oh, I dropped it. 1 second. I have my 3 different paper towel lengths: 1 centimeter, 2 centimeter, 3. Then it says we're going to put water in our cylinders. I'm just going to put the water in the cylinder. And cylinders. Down so you can see. And then we're going to drop some food coloring in there. And that's just because you can do it without food coloring if you don't have that at home. But I just dropped the food coloring in there so that we can see pretty colors and really observe it. Here, little drop. Just makes it pretty. All right, swirl that around, just let it mix up a little good. All right, so we're gonna place the paper towel. I'm gonna do one by one. Put it in here just so it touches, just till it touches the water. All right, and then here's 2 centimeters. A little wide, gotta fold it down in there. Stay in there, please. Sticking to my finger. All right, there we go. And then here's the last one. Fold it just a little bit. All right, and I'm gonna time it for 1 minute. I'm gonna do it in a minute from when I put the last paper towel in. And we're watching, and we're looking. All right, so it's been about a minute. So now we're gonna take them out. Lay them. Oop. All right, so you can see as I take them out, here's the first one. I'm just gonna lay it down over here so I can measure it. Second one. And here's the third. I'm going to measure the distance that the water traveled. For 1 centimeter, it traveled 11.7 centimeters. For the 2 centimeters, it traveled 10 centimeters. And for the 3 centimeters, it traveled 9.5. And I actually have to make a correction for the 2 centimeters because I didn't see that all the way up there. It was actually about 10.5 centimeters. So the 1 centimeter was 11.7, 2 centimeters was 10.5, and 3 centimeters was 9.5. So record that in your table, and then you're going to answer the questions. The questions, the first question, for example, asks you about a straw. Like what happens when you put a straw um, into a drink of water. It could be like a soda, it could be juice, it could be water, just whatever you put a straw in. Describe what happens when you do that. And then relate that to the property of heat, of adhesion, and think about an organism that depends on this property of water. And when I say organism, don't just think animals, think any type of organism, anything that's living. So, hope you enjoyed this lab demonstration. Go ahead and use this information to answer the questions and make sure you get your lab submitted on time. And then tomorrow you'll have notes to take related to this. But the other assignment that you will have for today is actually a reading and answering some questions. So, hope you've learned about the properties of water. See you another time.